Good people, we're doing this question. We are still under the series that we're doing of preparation of June exams. Remember, if you're writing grade 12 right now, financial math is going to be there. So grade 11 financial math, as much as you haven't learned the grade 12 one, but this one, definitely is going to be there. So we're doing some revision based on that financial math. Yeah, let's get going. The company brought a machinery costing 80,000 using the reducing balance method. The machinery had a book value of 20,000 after 5 years. Calculate the rate of the depreciation. I hope you still remember the equation of the rates where it's saying A is equals to P into 1 minus I and then into N. And then my A in this case, it's going to be 20,000, and then my P, it's going to be 80. So now let's substitute. It's going to be 20,000 equals to this 80,000 into 1 minus, remember looking for I, and then say after 5 years, so this is N, sorry, 5 years here. And then from here, we're going to divide by this 80,000, and then divide by 8,000 both sides. And then this cancels this give me the 0.25 equals to 1 minus into I into 5. How do we get rid of this 5? We're going to times by 1 over 5, and then we're going to times by 1 over 5 both sides, and then this is removed, we're left with 0.25 into this 1 over 5 is equals to 1 minus I. Remember looking for I, so we're going to take I to the other side, take this to the other side, so it's going to be I equals to 1 minus 0.25 into this 1 over 5, and then I in this case is going to be 0.242144417. And then remember looking for a rate, so my I, it's going to be times this by 100, so it's going to be 24.21%, which is the rate that they say they are looking for. Good people, now we're going to do 7.2. Calculate the effective rate interest rate if the interest compounded at 5% per annum and then compounded quarterly. Now remember, effective equation, or the equation where you need to calculate the effective rate, is not even on your question or question sheet, yes, or what do you call this thing? Formula sheet, yes, formula sheet, it's not there. Now, what is the equation saying? It's saying 1 plus I effective equals to 1 plus I norm all over. It's either you call it M or you call it N. It doesn't matter, depend on what your teacher says, and then into M. Remember looking for the I effective, so it's just 1 plus I effective. You substitute, this is 1, and then I nominal is this 5%, but remember this has to be in 0.5 in decimal places, and then this is, they say quarterly, so it's 4 into 4, and then looking for the I effective, so I effective is going to be 1, or this whole thing, 1 plus 0.05 over 4 into 4. Remember, take this 1 to the other side, so it's going to be minus 1. And then this thing in decimal places is 0.0509453336. Remember, looking for rate, then we times this whole thing by 100, and then my rate is 5.09% per annum. This is PA, per annum. So this is how we calculate the effective rate. Good people. SIPO invested 30,000 for 6 years. Sipo invested 30,000 for 6 years. So this is my T0. And then probably this is going to be my T6 here. And then the investment has an interest rate of 12% per annum compounded monthly for the first 2 years. So T2, it's going to be here for the first 2 years, it's 12%. And then thereafter, the interest rate changes to 10.8% per annum compounded semi-annually for the rest of the period. From T2 to T6 is just 10.8%. And then remember, they put it this 30,000 at T0. And then thereafter, okay, yeah, and then calculate the value of the investment at the end of the 6 years. Remember, there was no other transition that was made into an account. They just invested the 30,000. So A equals to P into 1 plus I into N. Now remember, is investing this 30,000, so invest this 30,000 into account, and then plus I, remember for the interest rate, it was 12%, so it's 0.12 all over compounded monthly, so it's 12 into for the first 2 years, meaning it's 2 times 12. Now remember, now after these 2 years, there's another interest that's going to accumulate here for the period of another 4 years. So we are going to put this interest here, which is just 1 plus the I in terms of this is 0.108 all over. Now remember, it's changing to the semi-annually, so it's going to be 2 into 4 times 2. Very important that you understand. That's why I've drawn the timeline also. And then after this, there are many ways of doing this thing. You can separate it and find the first one, and then after that, take the amount that is there and then you times it by this one. Still gonna give you exactly the same answer. So if I punch the calculator here, the amount that I get for the investment at the end of 6 years is just 58,000 and then 0.751 cent. This is the amount that we get at the end of 6 years. Okay, 7.4. Mary deposited 25,000 into a savings account with an interest rate of 18% per annum compounded monthly. Now, Mary withdraws 8,000 from the account 2 years after they deposited the initial amount. She deposited another 4,000 into this account 3.5 years after initial amount deposited. What amount will Mary have 5 years after making the initial deposit into this account? Now, Mary deposited 25,000 into the account. Now, A is equal to deposit 25,000. Now you ask yourself a question now in terms of answering the question, this question. You ask yourself a question: how many years does this 25,000 gonna stay in this account? So it's gonna stay for what? For 5 years. So we're gonna say plus 1 into, remember, compounded interest rate is 18%, so it's 0.18 into 12, and then 5 times 12. And then now, during these 5 years when it's still going, after 2 years, 80,000 or 8,000 was withdrew. So you ask yourself a question now: 8,000 is withdrew. After withdrawing this 80,000, how many years is left? 3 years is left. So it's going to be 1 plus 0.18 all over 12 into 3 times 12. Now, after 3.5 years after initial deposits, meaning this is T3 and then and a half here, he deposited another 4 thousand. Now you ask yourself a question: how many years is left after he deposit this is amount? We are left with, now you ask yourself, this is another half and then this is another year, meaning it's 1.5 year. So it's 1 plus 0.18 all over 12. Remember, this is a half and one full year, meaning it's 1.5, meaning 1.5, and then you times it by 12. And then if you can add this whole thing and get an answer, we are going to get 52,636,74 cents. Now, there's also another way of doing this question step by step, in terms of not doing as a one full thing like this one. So this is the only option that I choose in terms of this video, but there's another option in terms of doing breaking it down step by step. But the only trick in that step is to make sure that you don't round off your answers, because it's very important in the financial math to each and every cent counts.